Welcome to section 2.2, where we are getting into some actual trigonometric functions, and we begin with the unit circle approach, where if we know a point on the unit circle, then all we need to know is what relationship do each of the trigonometric functions have with that point. And so these are all within your book. So if we look at example number 1, we have the point 47 root 33 over 7, and we are asked to find the sine of t. Well, the sine of t is simply the y coordinate, and so the sine of t in this particular case would equal the y coordinate, which is root 33 over 7. Number 2 asks us to find the cotangent of t when the point is negative root 21 over 5, 2/5. And so the cotangent of t is the x value, which is negative root 21 over 5, over the y value, which is 2/5. And doing some simplification, we get negative square root of 21 over 2, and that's what the cotangent of t equals. Number 3, we have the point 3/4 and negative root 7/4, and what we are asked to do is to find the cosine of t. Well, the cosine of t is the x value, which in this particular case is simply 3/4. The next group of problems asks us to find exact values of these particular values, and it does not allow us to use the calculator, and so there are many ways to do this. I gave you a table in class which you will want to learn or remember, or be able to recreate, certainly at a minimum, and understand the cyclic nature of each one of these, and once it starts repeating, then just go on from there. And so what we begin with is the sine of 2 pi. Well, the first thing we really want to do is to realize where is the sine of 2 pi on a drawing. And we always begin here on the initial side, the positive x-axis, and we always go in a counterclockwise direction as long as this angle is positive. Well, 2 pi would just be one distance or one trip around, which is equivalent to the sine of 0, which the sine of 0 has the value of 0. Number 5, we want the cotangent of pi over 2. Well, the cotangent is the inverse of tangent, and so we would have to find the tangent of pi over 2. Looking back over here, pi over 2 takes us up here into this angle right here, and we're going to end right here. Well, the point on the unit circle for cotangent of pi over 2, okay, we've got, this is the point 0, 1, and we know, according to number 2, the cotangent is the x value over the y value. Well, the x value is 0, the y value is 1, and 0 over 1 equals 0. Number 6, the sine of 22 pi. Well, let's figure this out. We go around once, that's 2, 4, 6, and we keep on doing that over and over again until we eventually end up here. The point on the unit circle here is 1, 0, and the sine is always the y value. So in this case, that would be 0. And finally, 7 is the cosine of 45 degrees. Now this one's not quite so simple to calculate, and this is where we will want to use the table that I gave you a little bit earlier, or that I gave you in class, I apologize. And this would end up equaling, by memorization or by looking at that rather simple table, the square root of 2 over 2. Then we have several small sections. We begin with number 8. Number 8 says, we want to find f of theta, which is cotangent of theta, and we need to find f of theta when theta equals 45 degrees. So 8 becomes the problem. What is the cotangent of 45 degrees? Well, here we need to use our table and realize that cotangent is the reciprocal of tangent. So we look first off, what is the tangent of 45 degrees? We see that that is equal to 1. And so the cotangent of 45 degrees would be the reciprocal of 1, or 1 over 1, which still equals 1. And so the cotangent of 45 degrees is equal to 1. Find the exact value, not using the calculator, of the secant of 30 degrees. Well, here we need to realize the secant is the reciprocal of cosine. So the first thing we have to do is find what is the cosine of 30 degrees. Cosine of 30 degrees is the square root of 3 over 2. But so we need to find the reciprocal of that. So that would be 2 over the square root of 3. Now this is not good because we have this radical in the denominator. So we rationalize the denominator by multiplying both the numerator and denominator by the square root of 3, and we get 2 square root of 3 over 3. 10 and 11 asks us to find exact values, and here we're potentially going to be adding or subtracting, and once again we are not allowed to use calculators. So we have the secant of 60 degrees minus the sine of 60 degrees. Well, the secant of 60, or the secant, is the reciprocal of cosine. So we actually need to find what is the cosine of 60 degrees. Looking at our table, the cosine of 60 degrees would be 1/2. But we need the reciprocal of that. So the reciprocal of 1/2 is 2. The sine of 60 degrees, on the other hand, does come directly from that table, and that would be the square root of 3 over 2. Now, generally this would be an okay answer, but in trig we like to see most of our answers in one big involved fraction. And so what we're going to do is we're going to create one big fraction, the common denominator being a 2, which simply means this is going to become 4 minus the square root of 3, the whole quantity, over 2. Number 11, the tangent of pi over 6 minus the cosine of pi over 6. And both of these come directly from our table. So the tangent of pi over 6 is root 3 over 3, and the cosine of pi over 6 is root 3 over 2. Once again, we want to combine this into one fraction, and so it will have a common denominator of 6. This becomes 2 root 3. This becomes 3 root 3. And now we can combine the numerators because they are like terms, and so we get negative root 3 over 6. And this is as simple as this one gets, and so we have our final answer. Example 12 and 13. We are given a particular function. We are told theta equals 30 degrees, and we need to find a particular thing. Number 12, we asked what is f of theta? Well, f of theta simply is cotangent of theta, or in this case cotangent of 30 degrees. Once again, we need to find tangent first, then we will take the reciprocal of it to determine this. The tangent of 30 degrees is root 3 over 3. So the reciprocal would be 3 over square root of 3. Rationalizing the denominator, we get 3 root 3 over 3, and those 3's will simplify to the simple square root of 3. We need to find 11 f of theta, which simply means take 11 times, okay, f of theta in this case is cosine, the cosine of 30 degrees. Well, cosine of 30 degrees is directly in our table, so it is 11 times the square root of 3 over 2, which equals 11 root 3 over 2. Number 14 is a similar problem to the previous two. We're just asked to find f of theta when f of theta equals the sine of theta and theta equals 60 degrees. So this boils down to, what's the sine of 60 degrees? Well, the sine of 60 degrees is the square root of 3 over 2. Example number 15. We're actually getting into some radian measures here, which certainly makes a whole lot more sense. But we do need to do some calculations here. Mainly, we need to first of all determine, where does 16 pi over 3 end up? Well, if we go one complete revolution, that would actually be 2 pi, or putting it in terms of 3 over 3, that's 6 pi over 3. If we go around again, that's 12 pi over 3, and so we only have to go 4 pi over 3 more, which actually puts us over into this quadrant. And so we need to remember all students take calculus, and we notice that tangent and cotangent are the only positives here, so we know that the cosine will be negative. So that's the first thing we determine. What is the secant of that being negative? Now in what else we need to do is to find the reference angle. The reference angle here, it always goes to the closest x-axis, and so how much further beyond this x-axis did we go? We went pi over 3. So this becomes the equivalent of what is the cosine of pi over 3. Well, that is in our table, and the cosine of pi over 3 is 1/2. We've already determined that our secant is negative, and so our final answer is negative 1/2. And we will finish this section up in the next video.